Okay, good morning. Sam Martinez here, and we did a group project looking at casting a bar of soap out of a 3D printed mold. So that's what you're currently looking at in the screen. The inspiration for this part was something similar to this, a Dove bar of soap. If you actually pull it out of your cabinet, you can see where the parting line, where the mold halves come together. So that's what we were trying to duplicate here. So in the class, we usually discussed more of something like this, which would be like a sand mold design where you have a top facing going into a bottom gated part, and then you have your vent holes, and then a riser on the other side. We're a little bit limited by 3D printing because those mold halves have to release from each other. So went to a simpler design like this where it's directly running right into the part. The part is still drafted in order so that those two halves will be able to release from each other and the part will release. Then on the top, you still see the vent holes, but it's just a much simpler gating system in order to accommodate the at-home 3D printing nature of this project.
Next, we calculated the mold solidification time. This was used to find out how hot we needed to heat the soap so that we could pour it in time without the soap solidifying halfway through the pour. We used the equation given here to understand how fast the mold would solidify. We used the material properties of soap for the casting properties and the material properties of PLA for the mold properties. Our melting temperature of soap was 130 degrees Fahrenheit, and our room temperature was 73 degrees Fahrenheit. From the equation and the material properties, we were able to find a mold solidification time of 462 seconds. Finally, we used the solidification time to calculate how much we needed to superheat the soap to be able to pour it before it would begin to solidify. We used the superheating temperature equation. Assuming a 1-minute pouring time, we now have a total solidification time of 522 seconds. From this, we were able to calculate a delta T of 8.2 Kelvin. To get our pouring temperature, we added the delta T to our melting temperature to get a total pouring temperature of 144.8 degrees Fahrenheit. Now, on to the manufacturing. First, we 3D printed the mold. After the mold was printed, we assembled the two halves together and secured it with rubber bands. Next, we melted the soap base in the microwave. Once the soap reached 144.8 degrees Fahrenheit, it was ready to pour. We poured it into the mold. Once the mold was fully set, we separated the two halves of the mold to reveal the finished casting. The pouring basin and the sprue were still attached, so we separated those from the part to get our final finished soap.